All right, this is the answer key for exercise set 1.3. Answer key. Okay, so step number one, question one, graph f of x equals 1 half x minus 3 for x minus 2, x less than 2, and x squared minus 4 for x is greater than or equal to 2. So this is piecewise. We have two functions, 1 half x minus 3 and x squared minus 4, and they are separating at this point too. So just like visually, when we're graphing this, everything 2 and below, I'm following 1 half. So 1 half x minus 3, and everything 2 and above, I'm following x squared minus 4. So we're going to plot this. You're going to plug in x values, right? Always a good one to start with is 0. Plug in 0. 0 is going to go into the first one because it's less than 2. We're going to have 1 half 0 minus 3, which means that it's going to be 1 to negative 3. Okay, when I plug in 0 into this equation right here, when a 0 goes in, I get negative 3. That's how I get this point, right? If I look at this function, it's a slope of 1 half x. That means it goes over 2 up 1, right? So I can now fill in the rest of the blanks. Over 2 down 1, over 2 down 1. Connect these dots. This is the first half of the function. At 2, when to get to 2, see how it's less than 2? That means at this point, it's actually going to be an open circle here at this point. Okay? So this is 1 half x minus 3, right? Now at 2, it switches, right? You can see that here. It switches from 1 half x minus 3 to x squared minus 4. Okay? X squared minus 4. We're going to plug in 2 because we're picking up at 2. I want to plug in 2 to this. So we're going to get 2 squared minus 4 equals 0. That's 4 minus 4, that's 0. It means when I plug in a 2, I will get a 0. When I plug in a 3, 3 squared is 9. 9 minus 4 is 5. If you guys are having trouble plotting it, like make a table, right? Make a table, make an X, make a Y, plug in the values, and then plot them. Like if that's like an extra step you can do. If this is like a rush for you, just plug in X values, find the Y, and then plot them here. Okay. Graph continuous, no. Break at 2. Break at x equals 2. You can see that visually right here at x equals 2. Domain and range. So D domain is actually all real numbers, negative infinity to infinity, because even though we have this hole here at 2, since it's filled above it and open below, it's valid. Like when I plug in 2, I get 0. 2 does work. 2 is part of the domain. So it's included. Our range, this one is going to be 2 intervals. We're going to have negative infinity. We're going to start, it's going to go down forever, right? This is going down forever. But it's going to come up here. It's actually going to break at negative 2. So at negative 2, we're going to have a break. And then we're going to have a union and an end. We're going to pick up at 0 and then continue to infinity. Okay, that's 0 to infinity right here. So the break, what I'm not including is from negative 2 to 2. That's not in this. Notice that this is a bracket here because it's solid on the 0, and this is an open parentheses because it's open on the negative 2. Okay, f of 0, f of 2, f of 4. You're just plugging in values into the right part of the function. So for 0, it's less than 2, so it's going to go into 1 half 0 minus 3, which is negative 3. F of 2 is equal to 2, so it's going to go into my second one. So it's going to be 2 squared minus 4, which is 0. And then lastly, f of 4, that is greater than 2, so it's going to go into this function, is 4 squared minus 4, which is 16 minus 4, which is 12. Okay, so 12, 0, and negative 3. All right, next one. We're finding the wholes and asymptotes of this rational function. So I'm going to rewrite it here. X squared plus 4x plus 4 plus over x squared minus 4. Your first step, whenever you come across a rational function, you're asked to find asymptotes of wholes, you want to factor it if possible. Factor if possible. So this is what we're going to do. Factor. So if we look at x squared minus 4, the factors of x squared minus 4, like, okay, this is a special one called the difference of squares. You want two numbers that add to get 0, multiply to get negative 4. There's a 2 and negative 2. So we have x plus 2, x minus 2. And this top one, I can see this is a perfect square, right? You're going to do the same thing, 4 on top, 4 on bottom, and it's 2 and 2, right? 2 plus 2 is 4, 2 times 2 is 4. So we have x plus 2, x minus 2, and then on top we have x plus 2, x plus 2. Okay. Now we are going to identify our holes asymptotes. Okay, so first, holes. Holes happen when you have a 0 in the denominator and the numerator. So I'm going to have a 0 right here at x equals negative 2. Like when I plug in negative 2 into this, I'll get 0. And I also have that in the numerator. So that means, I'm going to circle this. This is a hole at x equals negative 2. Okay. This x minus 2 does not appear in the numerator. When it's a 0 only in the denominator, this value right here is a vertical asymptote. I'm going to say VA at x equals 2. Okay, so hole at negative 2, VA at 2. Now we need the horizontal asymptote. So the horizontal asymptote, if you remember from toolkit 1.2, there's 3 conditions for the horizontal asymptote. If the degree, so remember degree is the exponent. If the degree in the top and the bottom are the same, so you have this degree 2 and degree 2, you divide that highest exponent, and the result is the horizontal asymptote. So since they have the same degree, I divide the two x squareds and I get a 1. This means that I have a horizontal asymptote at y equals 1. Okay, so now that I have my asymptotes, my holes, my hole, that's it. I'm going to go back up and I'm going to plot them. So I have a horizontal asymptote at y equals 1. When you're plotting your graph, you want to actually start by plotting the asymptotes. So this is y equals 1. This is the HA, horizontal asymptote. And then you're going to have a vertical asymptote at x equals 2. So I'm going to draw a dotted line here. This is x equals 2, vertical asymptote. And now I know I have a hole at x equals negative 2. To find the y value of the hole, you're going to take this and plug it back into this equation, but you're going to leave out the hole that we have. So I'm going to rewrite this and explain that. So in factored form, we would have x plus 2 over x plus 2, x minus 2. If I simplify this, I would cancel out this, and I'd only have x plus 2 over x minus 2. At this point, you take that whole value, that negative 2, and put it into the equation. And you're going to get 0 over negative 4, which is 0. So that means the whole happens at negative 2, comma 0. Okay, that 0 is this, the x is this. Okay, so at negative 2, 0 right here, I'll have a hole. So horizontal asymptote, vertical asymptote, hole at negative 2. Now it's about just sketching around the asymptotes. You know the function is going to always be heading towards them. So you're just going to follow along and make sure they are ending towards them. Okay. We're not going to do part C for this. I will do domain and range. So I'm gonna answer domain and range right here. D, domain, is everything from negative infinity up until negative 2. Then we do negative 2 up until 2. And then we do 2 to infinity. For the range, it's everything from negative infinity up until 0. And then from 0 to 1. And then from 1 to infinity. Okay. And that's the first page. Okay, this is page 2 of exercise set 1.3. Number 3, which the graph best fits the function given in the table. So this is our x, this is our input, this is our output. As our input is going up, our f of x is increasing. However, it's not a 1-to-1 ratio. Like if you look closely, I know that it looks like the output's increasing by 1 each time, but the x is increasing by, first it's 1, then it's 2, then it's 3, then it's 4, then it's 5, then it's 6, then it's 7, 8, 9, which means that the slope is actually getting shallower as we go along, because it takes more x's to go up 1 unit. So it's going to be b. Okay, you can imagine like we start steep, like with a slope of 1, then we get shallower, 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 shallower. So the slope is getting shallower in this function. Okay. Polynomial division. Okay, this is what we've been doing in class. This one's a little bit tricky because we need a placeholder, x cubed plus a 0x squared. Notice in our function, say we don't have an x squared, you got to put a placeholder here. Okay, minus 4x plus 6. And on the outside, x minus 1, and then you multiply. What times x is x cubed? That's x squared. X squared times x is x cubed. X squared times negative 1 is negative x squared. Subtract the whole thing. X cubed, these cancel. Minus and negative is plus, so it's just positive x squared. I'm going to drop down the negative 4x. Again, what times x is x squared? That's going to be a regular x. X times x, x squared minus x, subtract the whole thing, cancel, cancel. Negative 4x minus negative x is negative 3x. Drop down to 6. Again, one more time. What times x is negative 3x? That'd be negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 1 is 3. Subtract the whole thing. Cancel, cancel. 6 minus 3 is 3. This is my remainder. So my answer is this plus my remainder. I'll write it over here, x squared plus x minus 3 plus 3 over x minus 1. That is my solution. Okay. Last one, number 5. We have a composite function, j of g of x. Okay, so j of x is 1 over x. Okay, so it's going to be 1 over, and then I'm going to put my inside function to replace x. So my inside function is this whole thing right here, square root of x minus 1 over x plus 2. When you do 1 over a fraction, it flips the fraction. So what you end up with is x plus 2 over the square root of x minus 1. From here, we need the domain. So remember, you can't get 0 in the denominator. So 1 is not going to work. You can't have 1. And you also cannot square root any negative numbers. So not only is 1 is not going to work, but anything less than 1 is not going to work too. Like when I plug in 1, I'll get 0. That doesn't work. When I plug in 0, I get negative 1. That's also not going to work. Nothing below that's going to work. So it's just going to be all values from 1 to infinity. Everything above will work. Okay, but not including 1. That's why it's open here. Okay. Then we have an inverse. That's what we did today. Inverse of h of x. Where is h? H of x is 4 minus 6x squared. You rewrite it with a y. You flip them. So it's going to be x equals 4 minus 6y squared. Solve for y. Let's get rid of the 4. X minus 4 equals negative 6y squared. We're going to get rid of the negative 6 by dividing by negative 6. Negative 6, negative 6. These cancel. So this gives me, I'm going to rewrite it over here, and I'm going to flip it. Y squared equals x minus 4 over negative 6. Final step to get rid of the squares, the square root both sides. Y equals square root of x minus 4 over negative 6. That is my inverse. Okay.